Okay, for number 5 here, we have our function is cotangent. Notice they actually used the wrong variable here. It should be cotangent x if they're going to use that as x. In the interval, they give us this pi over 4 to 3 pi over 4. And we're looking for the average rate of change. So again, in the average rate of change problem, we're going to need to find the 2 points first. So that means we need cotangent of pi over 4. And cotangent of pi over 4 is the same as cosine pi over 4 by sine of pi over 4. And we know that cosine of pi over 4 and sine of pi over 4 are both radical 2 over 2, so the answer to this is 1. So pi over 4, 1 would be a point. And then 3 pi over 4, if we were to do the same thing here and plug in 3 pi over 4, both are still the same value. However, 1 would be positive, 1 would be negative. And 3 pi over 4 would be in the second quadrant, so sine is positive, cosine is negative, so it would be negative 1. And if we want to find the average rate of change between those two, we would find the slope. So if we do negative 1 minus 1 on top, 3 pi over 4 minus pi over 4 on the bottom, negative 2 on top, and on the bottom we'd get pi over 2. And instead of dividing by a fraction, we could multiply with the reciprocal with negative 4 over pi. Questions on any part of that one? Keeping in mind that when we have cotangent, when it's defined with a sign on the bottom, okay, we know the sign of is 0 at 0 and pi and 2 pi and so on. Okay, have we crossed an asymptote here at all? Is pi in the mix here? Pi over 2 is, but pi is not, is it? So we're okay there. What about for the other one when we go pi over 6 to pi over 2? For part B. Still, no asymptote issues here to deal with. We're not going to cross pi or 0 or 2 pi between those two. But ultimately, we still have to do the same thing in terms of figuring out what are the values here. So cosine of pi over 6 over sine of pi over 6. Cosine of pi over 6, we know what pi over 6 is the radical 3 over 2 value. Sine is the 1/2 value. And if we calculate, right up the radical 3. So pi over 6, radical 3 would be 1 point. And the other point, pi over 2. And when we do cosine pi over 2 or sine pi over 2, the cosine of pi over 2 is 0, sine of pi over 2 is 1, we get 0 for our y coordinate there. And once again, we'll find the slope between those two to find that average rate. And if we do that, we're going to get negative radical 3 on top. And on the bottom, if we have pi over 2 minus pi over 6, or pi over 2 would be 3 pi over 6. We get the common denominator. So it would be 2 pi over 6 if we subtract, or pi over 3 if we simplify. So final answer then would be negative 3 radical 3 over pi. Multiply by 3 over pi instead of divide by pi over 3. And good to go. Any questions on either the concept part, which is finding the average rate of change, matter of finding the 2 points that are the endpoints, or the mechanical part, which is the algebra that it took to find those slopes and those points? And for instance here, these values here, you know, this very well could be on the non-calculator part. Okay, you need to be able to come up with these values quickly. So if you don't know how to find values for pi over 6, pi over 3, pi over 4, pi over 2, pi, and so on, our key values where we know the answers without calculator, and that's something that you're going to need to practice. So if you can't do that right now, and if I were you, I'd probably come up and say something to me at some point, say, hey, I'm going to need to get some practice problems on those. Okay? Like I said, based on the unit circle, we should be able to find that location and know whether it's the pi over 3 or whether it's the 1/2 or the radical 3 over 2. You know that pi over 4 is always radical 2 over 2. There's really only 3 values you gotta memorize, so you guys need to be able to put the right one with the right location though. So that's something that, that you didn't learn well enough in pre-calc. That's something that you're gonna need to practice, and you better let me know, because like I said, that very well could be on the non-calculator part, and if you don't know it, then I guess you just get it wrong, right? Alright. Anything else on the first half, 1 through 16?
11.
And 11 we have y equals 1 over x minus 1. And it's at x equals 2 they want, and this time we're gonna find the slope of the curve at this point. So if we want the slope of the curve, we know that we're gonna have to do our process that we've been working on here for the last week and a half or so. And so to do the algebra on this, again, we're going to take a plus h, and we're going to put it into the function given. So that f of a plus h is going to look like a plus h minus 1. So we're replacing x with a plus h. So that is the f of a plus h part. Then we're going to subtract from that f of a, which would be a minus 1, and that would be all over h. Okay. And at this point, we still can't find the limit as h approaches 0, because putting an h 0 on the bottom there would give us 0 on the bottom, which doesn't do us any good. So the question is, what do we do then, algebra-wise, to get this into a different form, hopefully, so that we could directly evaluate? Well, bottom line is we have a complex fraction here. And so with a complex fraction, there's 2 ways to remedy that. One would be to multiply both top and bottom by the common denominator of what's making this complex. That's one. We could also get a common denominator and combine the 2 tops and then multiply by 1 over h and see what happens there. I prefer the first way, which is to multiply by the common denominator. And the common denominator, of course, being those 2 multiplied together. So that right there is the common denominator between those 2 fractions on top. Okay. You ever need a common denominator, remember if you had a 3 on the bottom and a 7 on the bottom, the common denominator would be 21. Because how did I get that? I took 7 and 3 and did what? Multiply them. So if we have run in doubt, could we always get a common denominator by just multiplying the 2 together? Always. So if we do that, on both top and bottom, and we multiply, which again we're taking this expression and we're distributing. Okay, what will happen then when we multiply this fraction by this stuff right here? Well, that and that would what? Cancel out. We'd be left with a minus 1. Okay. And then minus. And when we do this stuff times this, then the a minus 1s would cancel out, and we'd be left with a plus h minus 1. And then on the bottom, as I mentioned on Friday, I would not multiply this out right now. I mean, of course, we could just go ahead and expand all that stuff if we wanted to, but I would leave it in factored form as much as possible. Because hopefully something good is going to happen up top here and cancel out something, then I won't need to bother with multiplying that whole bottom out. Okay? So let's see if something good happens. If I were to subtract, which means I distribute into my parentheses a negative, I would have a minus a, which would be gone. I'd have negative 1 minus negative 1, which means negative 1 plus 1, which would be what? Gone. And then I'd have negative h. So ultimately, when doing that, I would have the following. Which, again, is convenient because the h's will cancel out. And that's excellent because we want those to cancel out. So we have answer would be negative 1, and then a plus h minus 1, a minus 1. And at this point, now we can try to take the limit as h approaches 0. And as h approaches 0, if I were to put a 0 in there, I'd still have negative 1 on top, and then here I'd have a minus 1 and a minus 1. So it would really just be a minus 1 all squared. And notice I did this one in general, because we didn't have to do it in general. We could have done it with the 2 if we wanted to, with the 2 in there instead of a. And our work might have been a little bit easier, but ultimately it's not much different if you do it with a letter or a number. So what's the advantage of doing it with a letter instead of a number is that now we have one that's good for any a value. Okay? And so once we know this, this is our answer for the slope indicator, if you will, the formula for finding the slope of this curve at any point. And if we put a 2 in there, we're going to get negative 1, 2 minus 1 squared, and we're going to wind up with negative 1 over 1, which is negative 1. So that would be our slope of this curve at that point. True. And from there, the part B says find the equation of the tangent. So if we're going to find the equation of the tangent, part B, we know that's going to start out y minus y1 equals m times x minus x1. We already know the slope, calculated that a minute ago. And then we also need a point. Well, the point here, the x value is 2, so we'd have x minus 2 here. And then the y value at 2 is 1 over 2 minus 1. So 1 over 2 minus 1 is 1. And there would be our answer for part B. And again, how many times out of 10 should we change this to a different form? 0. Okay. Part C, how about the equation for the normal line? The normal line is going to go through the same point. And the slope, the normal line and the tangent line are going to be perpendicular to each other. So those two slopes should be opposite and reciprocal. So therefore the slope of the normal line will just be 1. Opposite of negative 1, opposite and reciprocal. Of course, the reciprocal of 1 is itself. So whatever your tangent line is, the normal line is the line that is going to be perpendicular to the tangent line at that same point. So again, the point doesn't change. The only difference is your tangent and your normal are going to have two different slopes. Okay. And then finally, in part D, it says draw the graph of the curve, tangent line, and normal line in the same viewing window. And when they say that in the same viewing window, then part D would be calculator problem, just to see if that looks correct. So let's find out if it is, because this is going to verify that the work that we did is in fact accurate. And this would really be the only reason why you want to change your lines to slope-intercept form if you have to graph it, because you can't do it in point-slope form. So our one answer here then is going to be, could be negative x, and this would be plus 2, so it'll be plus 3, so it'll be negative x plus 3 we type in that one. And then the normal line, this is going to be x minus 2 on this side, and we'd add 1, so it'll be x minus 1. And so if we go with the standard window on that, and I'm going to do a zoom just so we can see the picture more clear. We zoom in on that point in question. Now it looks to me like the curve and the tangent line, those look pretty good there, true? But do the tangent line and the normal line look perpendicular? Not really. Okay. But remember, the actual physical screen for the calculator is wider than it is tall. True? Yeah. So therefore, that's not going to look necessarily perpendicular unless you do zoom square. You square up the screen. Now they look perpendicular, don't they? So again, what's the purpose in doing part D? I mean, it verifies that what we did looks pretty good, doesn't it? Looks like we're in good shape for our analysis part. Any questions on any part of that process? What else? 1 through 16. On 7, they're just asking us to find some slopes. We have this equation. We have the P point right here, which is at 2650. And in part A, they're asking us to find the slopes of the secants between P, which is this one, and Q1 down here. And Q1, if we look at the, looks like it's 10 and then maybe 220. So if we put a label on that, 10, 220. Again, these are just estimates, so you're just estimating what that point is. And so if you're going to find the slope, what are you going to do with these 2 points? 650 minus 220 over 20 minus 10, calculate the slope. So you're going to do that for PQ1, and then you're going to do that for PQ2 and PQ3, so you're just going to do that slope 5 times or whatever it is, 4 times. Okay. And then ultimately it says estimate the speed at that point. Every time that you do this, as you get closer to P, you're going to get closer to the true slope at P, right? So based on the numbers that you compile, then from there you can make an estimate for what that true slope is at P, and you know, again, it's just an estimate in this case. Because you're even at P, even at Q4, you're not terribly close to P, but a lot closer than P1. P to Q1, that is. Okay. What about the appropriate unit here? They ask us about appropriate unit. What are these measured in here? 650 and 220 are what? Meters. And 10 and 20 are measured in seconds. So what's the unit on this? Yeah, it's not a guess. I mean, look right at the graph. What are we doing? We're subtracting meters and we're subtracting seconds. So if we divide those two, we get meters per second, which is ultimately the speed at that point. Anything else 1 through 16? Second half, 17 through 33. 17. And 17, we have a piecewise function. And it says 1 over x and 4 minus x, 4. And our job is to determine whether the curve has a slope at the indicated point. Okay. And if it does, give it, and if not, explain why not. So, the 2 points in question here were to the left of 2, we're using this function. To the right of 2, we're using the bottom function. And we want to know, do we have a slope at 2? So, if we're going to find the slope for either one of these at 2, and again, we can find them at 2 or we can find them in general and then plug 2 in. It's up to you, basically, in this problem. But with that said, our setup then, if we use our limit statement, for the first function, which is 1 over x, if we were to put a plus h into 1 over x, it'd be 1 over a plus h minus 1 over a all over h. So we're taking a plus h and a, putting it into the function, and then from there, very similar to what we just did in the last problem, our common denominator here would be a plus h times h, or excuse me, times a. Writing, right? And if we do the distributing, in that first fraction, the a plus h's would cancel out and leave us with a. Second fraction, the a's would cancel out and leave us with a plus h. And here's another step where people generally get it wrong because they don't put parentheses around the a plus h here. So don't be that person that does that, please. And on the bottom we have that. Again, just like last time, don't expand that because ultimately we want that h to be gone. Hopefully we're going to be able to cross that out. And you can see pretty clearly that's going to happen because we have a minus a here and then minus h. So we wind up with negative h on top. H times a plus h times a. H's will cancel. We'll be left with negative 1. And on the bottom we'd have a plus h times a. Limit as h approaches 0 is going to be negative 1 over a squared then. So that right there would be our slope formula, if you will, for this function. And we want to know the answer at 2. Right? So the answer at 2 is going to be negative 1, 4. So the slope coming from the left would be negative 1/4. And we need to figure out, also do the same thing here, so it's basically 2 problems in one. What do we have for the slope of this one? Okay. Well, looking at this function, what is it? I mean, we can do this if we want to, but we shouldn't need to because what kind of function is this? Isn't it linear? I mean, if we wrote that as 1 minus 1/4 x, wouldn't that be the same thing as this? True? And ultimately, if it's linear, do we need to bother with all this? If it's linear, the slope isn't going to change no matter what point we're at, so what's the slope of this? Negative 1/4, isn't it? So at 2, what do we know about these two curves? They have exactly the same slope on either side. So therefore, is there a slope at that point? Yes. Yeah. And what is the answer? The answer is it's the 1/4. Negative.
For the limit at h approaches 0, why does the h go away and then h becomes a squared on the bottom?
Well, remember we're putting 0 in for h.
Okay.
If that's gone, then all we're going to have in parentheses is a. A times a would be a squared. And remember that last step, and sometimes we forget that last step, is always the limit as h approaches 0. So any h's that are there are going to become zeros. So, and again, we would have done that right at the beginning, but there was a 0 on the bottom if we would have done it at the beginning. True? That's why we have to do the algebra it takes to get down to something where we can actually directly evaluate it. Good question so far. What else? 17 through 33. 25. Now 25, it says, what is the rate of change of the area of a circle with respect to the radius when the radius is 3 inches? So we have our area formula when, and hopefully we know that the area of a circle is A equals pi r squared, right? And the question though says, what's the rate of change of the area with respect to the radius when the radius is 3 inches? Okay? So with that, again, the rate of change, you know, it's not between two things, so we're not looking for an average rate of change, we're looking for an instantaneous rate of change. So if this radius is changing, okay, getting bigger or smaller in some manner, okay, we want to know what's the instantaneous rate of change. Well, the instantaneous rate of change is always going to be this. So really it's the same problem that we just got done doing, except for it's just worded a little bit differently. We're still looking for an instantaneous rate of change, and in any case, whether we're dealing with circles or our speeds and whatnot, we're still going to use the same formula, if you will, for instantaneous rate of change. And so in our particular case, it's going to be pi times a plus h squared minus pi times a squared all over h. So on this one's essentially like a polynomial one, because pi r squared is essentially a polynomial function. So if we were to expand like normal, we'd get a squared plus 2ah plus h squared, and then pi a squared here. And when we distribute the pi, we'd have pi a squared here and pi a squared here negative. So conveniently those would be gone. Pi times 2ah would be 2 pi ah, and then pi h squared. But like normal, the h is on top. We can factor one out and cross the h out on the bottom. And our expression left would be 2 pi a plus pi h. We can cross out the h that we could factor on the top. And again, final step is always limit as h approaches 0. And so at that point our answer would be 2 pi a. And the question is, and keep in mind that the a is our radius here. Okay. So the final answer is 2 pi times what radius did they give us? So when the radius is 3, so we get 6 pi would be the final answer. Think about what would the units be on that? Six pi what? What is this telling us? We know it's a rate of change because we calculated an instantaneous rate of change in any capacity, but you know, what's it telling us about this circle? Think about what the graph would look like. If I were to graph this a equals pi r squared, it would essentially look like this, true? These would be a values, these would be r values. What's r measured in here in this problem? What is it? Inches? If this is inches, then what's a measured in then? It'd be inches squared, wouldn't it? And ultimately, if I'm finding a slope, I know I'm finding a slope, so slopes units are always going to be the y values over the x values, so it would be inches squared per inch. So keep in mind what that's telling us is that in this particular case, that when the radius is 3, okay, the rate of change is 6 pi inches squared per inch. So that means that at every inch, okay, the area is changing at a rate of 6 pi inches squared, then, isn't it? So this unit, you know, even looks kind of funny here because, you know, I think, well, can't we just cancel those and just get inches? But ultimately, it's a rate. It's inches squared per, you know, it's telling us how is the area of the circle changing as the radius changes. Which makes sense because if the radius gets bigger, what else has to get bigger? Yeah, the area has to get bigger also. Okay. Right. Any questions on that one? Others from the book? Alright, just a couple things about our book problems here. You know, no matter how many problems we have in a given day, you know, say you get to number 25 and you couldn't figure that out, okay? Make sure you don't stop then at 25 and don't look at the rest. You know, a lot of these problems are independent of one another. Okay, there might be a problem that's number 39 or whatever that's one that you can do with these. Okay, So they don't necessarily get harder as we go, right? They're different. Make sure that if you're gonna really do well in this class, that you need to try every one of these problems at night. I'm gonna tell you right now, if you spend more than 15 minutes trying to figure out this problem, or even probably less than that, okay, don't sit home at night for 3 hours and try to figure out these problems. If you're spending that much time on it, that's too much time. Okay? So when you're trying these problems, do your best that you can. If you can't figure it out, then bring it back the next day. But don't sit at home for 3 hours trying to figure out your homework problems. That makes sense? And if you can't figure it out within, a few minutes, at least some direction, put a mark on it and bring it back the next day. Okay? But at least give it a try and see if you can do something with it. If you can't, then that's what you want to ask about. But like I said, I don't want at conferences your parents telling me that you're spending 4 or 5 hours a night on your math homework, because that's ridiculous. So don't do that. How about the binder problems? When we take a look at those, I'll read the answers for any of it. Hard to read. Okay, the binder problem should have been the following. Should have been number 39 to start with. 39 should be true. And the reason is because the normal line is perpendicular to the tangent line at that point. Number 40 should be false, because there is no tangent at x equals 0. And at that point, remember we talked about we used that as our example actually on Friday, remember? When it comes to a v like that, there's no way we can draw one tangent line if there's a v. The slopes on either side would be totally different, so therefore there's no tangent line at that point. 41 should be D. 42 is E. 43 is C. 44 is A. And then for the quick quiz problems, number 1 is D. Number 2 is E. Number 3 is B. And number 4 in the free response, part A is -3. Part B is -3 minus 4h minus h squared. C is -4 minus h. And D is -4. Okay, how about questions, problems from anything in the binder group? On number 3, on the quick quiz, we have f of x equals 9 minus x squared. And it says which of the following is an equation for the tangent line at this point. So, and we want to know at the point x equals 2, keep in mind. And so the point in question here is 2, and if we plug a 2 in there, we're going to get 5. So 2, 5 is the point. So right off the bat, we can fill in 2 out of 3 blanks immediately. True? And our issue is just finding the slope then. And just for time's sake, we've done a lot of polynomials already. If we were to do our 9 minus a plus h squared minus 9 minus a squared all over h, and do the expansion, combine the like terms, and so on, we'd wind up with -2a is the answer. So we'll refrain from spending the time to go through all that again, but ultimately -2a is what you should wind up with for your slope formula. And if we put a 2 in there, we get -4. And so looking at those choices, we can see that they're in slope-intercept form. So this is a reason why we would change it to the other form. So y minus 5 would be -4 x plus 8. And if we add 5 to both sides, we get 13. And therefore it would match up with letter B. Questions on any part of that one? What else? else on the quick quiz or multiple choice?